Electrical calculator. COM is a useful online resource providing a variety of electrical calculators designed to simplify common electrical calculations. These calculators can assist electricians in performing accurate calculations for various applications. Firstly, voltage drop calculators are available to determine the voltage loss over a conductor length. This is crucial for ensuring that electrical equipment receives the proper voltage for optimal operation. Several factors influence voltage drop, including the conductor material, length, current, and temperature. Using a voltage drop calculator, one can input these parameters and quickly obtain the voltage drop percentage and the actual voltage at the load. This information is essential for selecting the correct conductor size to minimize voltage drop and prevent equipment malfunction or damage. Secondly, wire size calculators help determine the appropriate conductor size for a given electrical load. The correct wire size is vital for safety and efficiency, as undersized wires can overheat, leading to insulation damage, fire hazards, and voltage drop issues. Wire size calculators typically consider the ampacity of the wire, which is the maximum current the conductor can safely carry. Factors such as the ambient temperature, the number of conductors in a raceway, and the type of insulation affect the ampacity. By inputting the load current, voltage, distance, and other relevant factors, the calculator recommends the appropriate wire size based on applicable electrical codes and standards such as the National Electrical Code, specifically Table 310.15b16. Thirdly, conduit fill calculators are available to ensure that the number and size of conductors installed in a conduit do not exceed the maximum allowable fill percentage. Overfilling a conduit can make it difficult to pull wires, damage the insulation, and reduce the conduit's ability to dissipate heat. Conduit fill calculators take into account the type of conduit, the size of the conductors, and the number of conductors. The NEC provides specific guidelines for conduit fill in Chapter 9, Tables 1 through 7. These tables specify the maximum percentage of conduit area that can be occupied by conductors depending on the number and type of conductors. Fourthly, transformer calculators are useful for determining the appropriate transformer size and specifications for a given application. Transformers are essential components in electrical systems, used to step up or step down voltage levels to match the requirements of different equipment. Transformer calculators consider factors such as the input voltage, output voltage, and load demand. By inputting these parameters, the calculator can determine the required transformer kVA rating and suggest suitable transformer configurations. Fifthly, motor current calculators are helpful for determining the full load current, starting current, and other important parameters for electric motors. Motors are significant electrical loads in many industrial and commercial applications, and accurately calculating their current requirements is crucial for proper circuit protection and motor control. Motor current calculators typically consider the motor horsepower, voltage, and efficiency. The NEC provides tables such as 430.248 and 430.250 that list the full load currents for various motor types and sizes. Sixthly, Ohm's law calculators are available for quick calculations involving voltage, current, and resistance. Ohm's law, expressed as volts equals current times resistance, is a fundamental principle in electrical engineering. Ohm's law calculators can be used to solve for any one of these variables, given the other two. For example, if the voltage and resistance are known, the current can be calculated by dividing the voltage by the resistance. Seventhly, parallel resistance calculators simplify the calculation of the total resistance of multiple resistors connected in parallel. When resistors are connected in parallel, the total resistance is less than the smallest individual resistance. The formula for calculating the total resistance of parallel resistors is 1 divided by the sum of the reciprocals of the individual resistances. Eighthly, series resistance calculators allow for easy calculation of total resistance of resistors connected in series. When connected in series, the total resistance is the sum of the resistance value of each of the resistors. Ninthly, power factor calculators can be used to analyze the power factor of an alternating current circuit. Power factor is the ratio of real power, measured in kilowatts, to apparent power, measured in kVA. A low power factor indicates that the circuit is not efficiently using electrical power, leading to increased energy costs and potential equipment problems. Power factor correction can be achieved by adding capacitors to the circuit to offset the inductive reactance. Tenthly, short circuit current calculators are used to determine the maximum short circuit current that can occur at a specific point in an electrical system. Short circuit currents can be very high, potentially causing significant damage to equipment and posing safety hazards. Calculating the short circuit current is essential for selecting appropriate overcurrent protection devices, such as fuses and circuit breakers, to safely interrupt the fault current. The calculation typically involves considering the source impedance, transformer impedance, conductor impedance, and other factors. The NEC requires that electrical systems be designed and installed to withstand the available short-circuit current. The website's electrical calculators can be valuable tools for electricians, electrical engineers, and other professionals working in the electrical field. By providing quick and accurate calculations, these calculators can help to improve efficiency, safety, and accuracy in electrical work. It is important to note that these calculators are intended to be used as tools to aid in electrical calculations, and they should not be used as a substitute for proper electrical knowledge and training. Always consult with a qualified electrician or electrical engineer for complex or critical electrical calculations. And always refer to the latest edition of the National Electrical Code and other applicable codes and standards for specific requirements and guidelines. Additionally, the calculators can assist in determining the appropriate size of grounding and bonding conductors. Grounding and bonding are critical for electrical safety, as they provide a low impedance path for fault current to flow back to the source, allowing overcurrent protection devices to trip and clear the fault. The NEC specifies the required size of grounding and bonding conductors in Table 250.122, based on the size of the ungrounded conductors. Another useful application is calculating the demand load for various types of electrical equipment. Demand load is the maximum amount of power that an electrical system or component is expected to draw under normal operating conditions. Accurately calculating the demand load is essential for properly sizing electrical services, feeders, and branch circuits. The NEC provides guidelines for calculating demand loads for various types of equipment, such as lighting, appliances, and motors. The electrical calculators on the website can assist in performing these calculations, ensuring that the electrical system is adequately sized to handle the expected load. Furthermore, the calculators can aid in determining the energy consumption and cost of operating electrical equipment. Understanding the energy consumption of different devices is important for energy management and cost control. The calculators can estimate the energy consumption based on the power rating of the equipment and the operating hours. By inputting the cost of electricity, the calculator can also estimate the cost of operating the equipment over a given period. This information can be used to identify energy-saving opportunities and make informed decisions about equipment selection and operation. In addition to the specific calculators mentioned above, the website may also offer other useful tools and resources, such as electrical formulas, conversion charts, and wiring diagrams. These resources can provide valuable information and assistance for electricians and other electrical professionals. By utilizing these resources, one can enhance their knowledge and skills in the electrical field. The availability of these calculators and resources online makes it easy for electricians to access the information they need wherever they are working. This can save time and improve efficiency in the field. However, it is crucial to verify the accuracy of the results obtained from the calculators and to use them in conjunction with proper electrical knowledge and training. Always consult with a qualified electrician or electrical engineer for complex or critical electrical calculations, and always refer to the latest edition of the National Electrical Code and other applicable codes and standards for specific requirements and guidelines. It is also important to understand the limitations of the calculators and to use them appropriately. For example, some calculators may not be suitable for all types of electrical systems or applications. It is essential to carefully review the calculator's instructions and to ensure that it is appropriate for the specific task at hand. By using the electrical calculators on the website responsibly and in conjunction with proper electrical knowledge and training, one can improve their efficiency, safety, and accuracy in electrical work. These tools can be valuable assets for electricians and other electrical professionals, helping them to perform their jobs more effectively and safely. Remember that these calculators should be used as an aid in performing electrical calculations, and they should not be used as a replacement for proper electrical knowledge and training. It is always recommended to consult with a qualified electrician or electrical engineer for complex or critical electrical calculations, and to refer to the latest edition of the National Electrical Code and other applicable codes and standards for specific requirements and guidelines. Using a 120 volts or 240 volt source, for example, requires different wires and calculations than a 277 volts or 480 volt source.